central angle. We'll start with a central angle in a circle. Now, please don't draw the circle, but if I have a circle, there's many different angles I can make in there. I can make an angle that looks like that. I could make an angle that looks like that. Here's an angle, right? What makes an angle a central angle? Well, if you read through it, the vertex has to be on the center, okay? In a circle, if it's going to be defined as a central angle, the vertex has to be on the center. So in our case here, the central angle will be angle AOB in that circle. Why is it referred to as central? Again, the vertex is where? The center of the circle, okay? The center of the circle. And then you have an arc, which is a portion of the circle defined by two endpoints. So up here, we have a symbol for arc. It's like a little umbrella. So I could call arc AB. That's what that looks like. Arc, that's the arc symbol above it. Don't make it look like a segment symbol. Arc AB, which is referring to, everyone, this arc right here is arc AB. Now, since you guys are honors and you think ahead all the time, and I appreciate that, well, why couldn't I say this one's AB? And you could be right. But when I say AB, I mean directly from A to B, no points in between. If I wanted to refer to this arc right here, anybody know how I would name it instead? ACB. You can name it with more than two letters. That's fine. So arc ACB would be referring to this green one right here. Okay, so when you see the name of an arc, you go from one letter right to the next one, no points in between, no stops in between. Okay? Hey, how many degrees in a circle? 360, right? How can I find the number of degrees in a portion of an arc? Here's how. Here's your first circle theorem or fact, and that is the measure of a central angle and we all know what a central angle is now, is equal to the measure of its, I'm going to use a big word here, intercepted arc. And I'll just let you get that in, give you a chance to breathe for a second, and we'll discuss what that means. Hey, name my central angle again. What's the central angle in my diagram? AOB. So angle AOB will be the exact same degree measure as its arc that it creates. What arc does AOB create? AB. So whatever the degree measure of AOB is, it's the same measure as arc AB. Same measure. The central angle and the arc will always have the same measures. So if the angle's 70, so is the arc. That's 70 degrees out of 360. They're always the same. Everyone all good? All right, we'll get back to that one in a second. Semicircle. We've heard of that one before? Half a circle. Okay? Go down to my diagram right now. Name an arc that would be considered a semicircle. Name an arc that would be considered a semicircle. Can he do it again? Nope, but he's not going to try anymore. Okay, here we go. 9. Name a semicircle up here. TS. Fine. And I know which arc he's talking about because I go right from, ready everybody? T to S. Is there another semicircle here? Name it. TRS. Yep, good. And just make a quick note. Anybody know how many degrees in a semicircle? Half of 360, right? 180 degrees. All right. Major arc, something that measures bigger than a semicircle. So an arc that measures bigger than a semicircle. going to ask somebody right now, can you identify in this first diagram a major arc, something that is bigger than a semicircle right now? Here you go, 22. What do you got for me? Yes. Something, an arc that is larger than a semicircle. Perfect. RTS. Are we okay? Why that's considered a major? And then what if it's smaller than a semicircle? We call it a minor arc. You got a major arc and a minor arc. Something that's smaller than 180 degrees. So in that first diagram, what do you got for me here? 26? RT. Could you have picked a different one? What's another minor arc up here? RS, SR, however you wanted to define that one. Yep. Okay, in your groups right now, in this set, because both of these diagrams, as you notice, are the same. In this first one, I'd like you and your group to identify a minor arc. And in the third one, I'd like you to identify a major arc in the third one. There's no diameter in these two. That one has a diameter. So they're not the same. Okay. $28. Have a minor arc for me? RS. Anybody have RT, TR? That's fine. Okay. How about a major arc now? A major arc. Hey, 23, what do you got for me? Major arc? RTS, yep. Or STR, doesn't matter the order you put it there. All good? Major arc, minor arc, central angle. We got a lot going already. Are we going too fast? You guys picking it up? We're all right? Okay, one last vocabulary term here, and that is what if two arcs are next to each other? Adjacent arcs. All right, two arcs that share an endpoint. Okay, two arcs that share an endpoint. And it's just like you guys have known for years in math, adjacent usually means next to. Yes, two arcs next to each other. So anybody right now can identify two adjacent arcs on my diagram. Two adjacent arcs. There's a lot. There's a couple pairs here. All right, couple pairs. Evan, what do you got, stud? Okay, CA. So arc CA and arc AB. They both share which point, Evan? A. Okay. Could I have gone CB and BA? Yeah, absolutely. AC and CB. A lot of different options. All good. All right, remember the fact we just went over, previous page. Central angle is always equal to the measure of its arc. Those two are always the same. We're going to apply it now. Circle C. Hey, quick review from yesterday. If they're calling it circle C, what do I know about C? It's the center, and that's pretty useful here because if C is the center, what's EB then? Name EB. That's a what in the circle? Diameter. Perfect. All right, let's roll now. First thing, find the measure. And when we look for measure in degrees, how many degrees are in arc AE? Well, if you go back to the theorem you wrote down, the arc and the central angle are both the same. So if you can find the central angle, you know what the arc is. Who's got 19? All right, I don't want the answer, Maya. Here's what I want, though. What central angle creates arc AE? Get more specific. ACE, good. Anybody, how many degrees now are in ACE? Because that'll be my answer. How many degrees are in ACE? Come on, let's roll. 18? 90 degrees. So that means arc AE will also be 90 degrees. Do we see how that theorem's working now? Central angle, always equal to the arc measure. ED, arc ED. How many degrees in arc ED? 14. 50. 50? Because that's what its central angle is going to be. We are on a roll. DBA in that order. Follow the letters. DBA. 23, what do you got for me? 220 degrees. Can I answer anybody's questions before we keep going? AED. Again, follow the letters. A to E to D. That arc. 2, what do you got? $1.40. Great job. ABD. Already been asked. 26. 220. It's the same as DBA. Oh, wish I noticed that. And finally, arc BD. Let's finish this up strong. 27. $1.30. Central angle is equal to its intercepted arc measure. All good? Oh, yeah, you guys remember the days in elementary school. How many of you made some pie graphs, huh? Some pie charts? Back in the day, yep, we went around, surveyed each other. What shows do you watch, or what's your favorite color? Nobody cared, but you did it anyway. All right, here's the problem, though. There are no degree measures here. There are percents now. And I'm looking for arc BC. What is the measure of arc BC? But I do not know any angles like I did in the previous example. But I do know it's 18% of the whole thing. Ooh, suggestions. We got some suggestions here on how I can produce a degree measure if I know that part is 18% of the whole circle. 15? What are you suggesting I do here? 18% of 360. So I got to ask you guys, because the algebra skills aren't what they used to be for me. 360 times 18? No, that's a little silly because you're going to get a number bigger than 360. Multiply it by 0.18. Good. And what do you end up with there, Jack? 64.8 degrees. Yep. And that's this central angle, which means that's its arc measure. Yep. And I should have deleted this. I didn't revise this as well as I should have. When I asked this next question, find arc CD. Okay, it's 64.8. Great. You're not getting off the hook that easy. I'm going to add it to part C. You're welcome, honors. Not that I'm trying to catch anybody here, but I just got to remember AFD, please. Find the measure of arc AFD. I do not need to name it AFED. You guys, again, follow the letters. A to F to D. That's that whole arc, including E. $20, whenever you're ready. There you go. Okay. Any questions from you guys? Because I'm going to go in a little bit different mode now. We okay? Find a degree measure. Here's what we've been doing the first half of class. You guys have been finding, out of 360, how many degrees are in this certain arc. Here's what I'm going to do now. Now, I want to actually figure out how long the arc is. All right, so how many inches, how many centimeters are in the arc? We know how to find how many degrees are in the arc out of 360. Now I'm going to show you, actually, I take BC, stretch it out. How long is it? That's what we're about to do. See the difference between the two, though, before I show you how to do it. Everybody good what we're about to do? You know how to find, out of 360, how many degrees are in the arc. Now I want to find actually how long the darn thing is. Let's do it. Okay? So this is arc length. Not, hey, listen, not the measure of an arc. That's what we did the first half of class. Now I'm actually looking for how long is the darn thing. All right? How long is it? All right, so here's the formula, which is not given to you, unfortunately. So this is one you're going to have to, on your own, remember. The length of an arc is equal to, here we go, the measure of the arc and that's what we've been finding the first half of class. How many degrees are in the arc out of 360 times, and what I'm about to put should look pretty familiar from yesterday. What did we talk about? What was the big concept from yesterday? Big concept from yesterday? Times its circumference. That's how I'm going to find the length of the arc. All right, the length. Everybody okay? Ready to help me find a couple here? Find the length, leave your answer in terms of pi. Stop. I got to make sure we review every single moment we can review. Leave in terms of pi. What did that mean from yesterday? In your answer, you should have a pi. Don't hit the pi button on your calculator. All right, so what is the length? The length of arc AB here. Well, the first thing we need to find is what's the measure of it? How many degrees are in that arc? And that's what we did the first half of class. So here we go. How many degrees are in that arc? 19. How many degrees are in that arc? 90, because the central angle is 90. Out of 360 times the circumference, pi, diameter looks like it's 24. And remember, what are we keeping it in terms of? Pi. So it's going to be something pi. And in my calculator, all I need to do is 90 over 360 times, not 24 pi, just times 24. And how long is that arc now? 23? 6 pi. Yep. And you know I'm coming down strong this unit. What's missing? Inches. 6 pi inches. That's how long it is. And if you want to know actually how long it is, multiply 6 times pi. That's how many inches it is. Whoa! 2 CDE. I want the measure of arc, or the length of arc CDE. Given that that's 40, but 40 is not going into my formula. 40 is not going into my formula. All right, little help. 4, you ready back there, stud? What is the measure of CDE? Because it's not 40. 40 is the measure of arc CE. So what would be the measure of arc CDE? How many degrees in a circle? I know part of it's 40, and I'm looking for the other part, right? So it should be? What do you got for me? 320. Everyone see why I'm using 320 in the formula? Out of 360 times pi. What did they give me there, Skylar? What's that 9 representing? Radius, so I'll double it and get 18 for the diameter. Leave pi in your answer. Answer with units. What do you got for me here? 28. 16 pi centimeters. Nothing at all. And number 3, FH. Now, there's a lot of stuff going on over here, but I'm looking for FH, which means what? F to H, nothing in between. So I know there's a lot of stuff that was given on this side of the circle, but F to H, I'm asking you guys to find the length of that arc. So what is the measure first of that arc? 20, what's the measure of that arc? 435? Comment, whoa, comment down. 200 and 25. You all right back there? Okay. You're just getting rattled. It's okay. Happens to the great ones. Times. All right. Redeem yourself. What's the 3 meters? Radius, so diameter. There you go. 6 pi times 6. Keep that pi in the answer. Yes, you are going to have a decimal, but it's nothing too large, so we can just write it down. Or fraction form, I don't care. Fraction or decimal. And what do we end up? Here's from some more voices here. Whoa, 12. 3.75 meters. Okay. Okay, before I do this last honors type one, is everyone all right? The difference between the measure of an arc and the length of an arc. Measure is in what type of units? Degrees. Length could be inches, centimeters, meters. All right, that's how long it is. All right, you ready for this honors one, Saad? Oh, I guess I'm not. Okay, that was good. Looks like here it is. All right, had a little blank one. Sorry, I don't want to. I don't want to jip you out of a Promethean, man. Sorry. Nope, sorry. There you go. Never mind. All right, find the circumference. Hook me up with a formula. Let's go. Hook me up with a formula here. Circumference. Need a formula. 15. What's the formula? Pi d. Got it. And what did I give you? Length of JK, seriously, is 6.09. Anybody? Carolyn back there? No? Nobody on that one? Sorry. You guys are too focused and too... Arc JK, and I said, seriously? Never mind. Forget it. Forget it. Cherry pies are delicious. Anybody going? Coffee pie donuts? All right, forget you all. Like, I literally might just stand here and just start talking to the whiteboard because that's the same response I get back. 6.09. By the way, there was a top 5 joke of the week on the assignment sheet. Anybody see that? Why'd the big cat get an F on his report card? Because he was a cheetah, All right, never mind. Why? Why do I even try? So I know the length is 6.09. They give me the central angle is 50. In circumference, what's the only value you need to know to plug in? Diameter. So I need help finding the diameter of this circle given these 2 values. Well, again, let's start here. What's the 6.09 again? That's my arc length. It came from a formula we've been using. 6.09, how is that produced? By, what's the formula? 20, who's got 26? Okay, Lauren, let's go. Don't screw this up. Arc length is equal to what? Okay, stop. Measure of the arc, what is it? 50 over 360 times pi d. Do I know the diameter? Nope. Hey, whoa, whoa, whoa. Who told me? I think it would maybe Frank spit it out. I don't know. What's the only value I need here? Diameter, but hey, what is that there? What's pi d? Circumference. Do I need to really find the diameter and then re-plug it in here? No, get this by itself. This is the circumference. That's what I'm looking for in this problem, is find the circumference. Get this by itself, and you got the circumference. Do you see why there's no need to solve for d? You could, but you're just doing the same thing twice and plugging it back in. All right, so algebra skills taking over. How do I get pi d all by itself? What do I have to do with this 50 over 360 to get it out of there? You can do it in 1 step or you can do it in 2. I don't care. Let your famous algebraic skills take over. 27, got any thoughts? Here we go. Worse? Okay, well, 50 over 3. What's in the denominator? And it's being divided, right? So how do you think I get it out of there? Multiply both sides by 360. All right. We've been down this road. We're good. 2192.4 equal to 50 pi d. And if I did it this way, what would be the next step to get pi d by itself? 20. Divide by 50. Did anybody just multiply by 360 over 50? You could do that, multiply the reciprocal. That's because you're a stud, Luke. That's why you did that. All right. So pi d is going to be equal to, we're rounding to the nearest tenth, right? I have 43. I'll take this one, 43.8. 43.8. I'm not looking for confirmation. Inches, thank you. And again, do you guys see why you do not need to divide by pi? This is circumference right here. All right, this is circumference. All right, well, there's going to be two, I think two on the homework similar to that one. Questions, comments? All right, nice job. Go on to something different tomorrow. More new vocab. Not bad.